Welcome to This Explainer. You know, it's pretty wild to think about how human civilizations historically always sprouted up along the banks of rivers, lakes, and oceans. But our reliance on water isn't just some external historical fact. Our very own bodies are fundamentally built around it. Today, we're diving deep into the science of hydration, breaking down exactly how this incredible substance keeps us all alive.
Okay, let's dive into this. Here is our roadmap for today. We'll be looking at the magic water molecule, our inner ocean, the balancing act of bodily fluids, why hydration matters, and how to defeat dehydration.
Starting with Section 1, the magic water molecule, the atomic secret to life.
Water makes up more than 50% of our body weight, and it's literally the driver behind every single biochemical reaction happening in your cells right now. To understand why it's so powerful, we kind of have to look at its shape. It's a V-shaped molecule made of 2 hydrogen atoms and a single oxygen atom, good old H2O. But what makes it truly special is that it forms a dipole. See, the hydrogen and oxygen share a single electron, but that sharing is totally unbalanced. Because the electron zips around and spends way more time near the oxygen ends up with a partial negative charge, leaving the hydrogens with a partial positive charge. This lopsided nature is the true atomic secret to life.
And because of this dipole, the slightly positive hydrogens of one water molecule can beautifully line up with the slightly negative oxygen atoms of another. This magnetic attraction is called a hydrogen bond. Think of those perfectly round dew droplets you see sitting on leaves early in the morning. They huddle together exactly like that because millions of tiny hydrogen bonds are holding them tight. This exact same dipole chemistry makes water the ultimate universal solvent. Its charged ends can literally pull apart other molecules, easily dissolving sugars and salts right into it.
Let's move to Section 2 and see how this builds. Our inner ocean. Where does all that water actually go? Now, what's really interesting about this slide is just how much of this inner ocean is locked away where we can't even see it. It's staggering. If we assume a person's total water makes up about 60% of their body weight, a massive 2/3 of that water, which is roughly 40% of your entire body weight, is intracellular fluid. That means it is physically locked inside your cells. The remaining 1/3 is extracellular fluid, just floating around outside the cells and your blood and the tissue in between.
Within all these internal compartments, water is constantly busy acting as that universal solvent we just talked about. It's dissolving electrically charged molecules called electrolytes. It's like a giant puzzle. The slightly negative oxygen in the water attracts the positive electrolytes you see here, things like sodium, potassium, calcium, and magnesium. Meanwhile, the positive hydrogen attracts the negative team, chloride, bicarbonate, phosphate, and sulfate. Our body is incredibly meticulous about keeping these specific teams separated at very, very specific concentrations.
And the way our body maintains those strict concentrations is through a natural process called osmosis. Basically, osmosis is when water shifts from a more dilute area to a more concentrated one, just to perfectly balance out all those dissolved substances. A great way to measure your hydration status is by looking at your blood osmolarity. Normally, it sits right at a perfect baseline of around 300 milliosmoles per liter. If that number starts creeping up too high, it means your blood is getting way too concentrated, which is a classic red flag that there just isn't enough water in your system.
Which brings us to Section 3, the balancing act, the daily math of ins and outs.
So maintaining that perfect 300 milliosmoles requires a really active biological accounting system. Our survival literally hinges on constantly matching what we consume with what we eliminate. Let's walk through this balance sheet together. On the intake side, about 80% of our water comes from drinking fluids. And by the way, plain water is definitely ideal, but all fluids, yes, even your caffeinated coffee or tea, actually count toward that 80%. The other 20% comes from the foods we eat, especially water-rich fruits like watermelon or strawberries, which can be up to 90% water by weight. On the output side, we're constantly eliminating this water through breathing, sweating, urinating, and bowel movements. Let's break down exactly how water exits the body. Even when we're just resting, every single heartbeat propels 25% of our blood straight to the kidneys to be filtered. When you're properly hydrated, this produces somewhere between 800 and 2,000 milliliters of urine a day. And, as our source tastefully jokes, healthy urine should look a bit like pale yellow lemonade, though I certainly hope you aren't drinking any right now. We also lose about 200 milliliters a day during bowel movements and another 500 to 700 milliliters through our sweat glands. And remember, that sweat number spikes dramatically if you're nervous, exercising, or just hanging out in the heat.
But beyond the obvious ways we lose water, I really want to emphasize this high-end number right here, 900. Every single day, we can lose up to 900 milliliters of water through what scientists call insensible losses. They're called insensible because, well, we aren't even aware they're happening. Every time you breathe out, water vapor leaves your body to humidify the air. Water is also constantly diffusing right through the layers of your skin and simply evaporating. That is an incredible amount of water just vanishing into thin air without you even noticing.
When you start adding up the urine, the sweat, and all those sneaky, insensible losses, the daily math of our bodily output is kind of mind-blowing. And this directly connects to why we have specific daily recommended fluid goals. Beyond the water we get from food, the recommended daily fluid intake is roughly 2.2 liters. That's about 11 glasses for women. For men, it's about 3 liters or 13 glasses. This is the exact volume you need to consume just to balance out the basic math of living.
And this brilliantly illustrates Section 4, why hydration matters, keeping the machine running.
Keeping that delicate mathematical balance isn't just about trying not to feel thirsty. It is absolutely crucial for operating the massive biological machinery inside you. Just look at the sheer variety of tasks water handles. It forms the tears, mucus, and saliva that lubricate your body's entryways. Internally, it literally stops your bones from rubbing together by creating synovial fluid for your joints. It's essential for digestion, forming the fluid environment of gastric juices so enzymes can actually break down your meals. Water provides the bulk of your blood to make sure oxygen gets transported. It even dilates the capillaries in your skin so you can sweat out heat when you're working out, and constricts them to retain heat when you're cold. It really does the whole shebang.
Because water is so deeply integrated into every single bodily function, the stakes here are incredibly immediate. If you lose just 2% of your body weight due to water loss, your internal machine starts malfunctioning. A tiny 2% dip can instantly sabotage your brain function, causing irritability, sharp headaches, and a really profound difficulty concentrating. Which brings us to our final section, Section 5, Defeating Dehydration, Spotting the Signs and Staying Ahead. At its core, dehydration is simply what happens when your outs exceed your ins. When we fail that daily math and those bodily losses start outweighing our intake, our body throws up some serious physiological alarms. Here's a rapid-fire checklist of warning signs to watch out for throughout your day. It usually starts with thirst and a dry mouth or dry lips. Then comes the nausea, fatigue, and maybe some lightheadedness. You'll also likely notice a darkening of your urine color or a pretty sharp decrease in how often you actually need to go to the bathroom. Now, while we all need to be watching out for these signs, specific groups are uniquely vulnerable here. Children, for example, are highly at risk. They need about 1.7 liters daily, but their thirst sensors aren't fully developed yet, so they rely completely on caregivers. Interestingly enough, research shows that proper hydration directly boosts a child's school performance and concentration. The elderly are also at a much higher risk because of a decreased sensation of thirst, altered kidney function from chronic diseases, and various medications. Finally, travelers sitting on airplanes for more than 2 hours face incredibly dry cabin air, and athletes or physical laborers are losing vast amounts of water and electrolytes through heavy sweating.
So, the crucial point is this. The absolute best way to avoid dehydration isn't just waiting around until you feel like you need water. It's monitoring your output, like your urine color, and proactively sipping fluids. Because honestly, once that thirst sensation finally registers in your brain, dehydration is already underway. Your body has already hit the panic button.
Which leaves us with one final provocative question to wrap up this explainer. Think about your own daily habits, all the incredible microscopic processes keeping you alive, and that constant mathematical balance of ins and outs. Are you drinking before you're thirsty? Thank you so much for exploring the science of hydration with me today. Now make sure to go grab a big glass of water on your way out.